This video is on graphing reciprocal functions. The parent reciprocal function is f of x equals 1 over x. And here's a graph of what that looks like. You'll notice that there are two pieces to the reciprocal function graph. One piece here in the first quadrant, which kind of looks like it's heading out in this direction, doesn't quite hit the x-axis, and part that doesn't quite hit the y-axis, and then another part over here in the third quadrant that looks like this. As with most of the other functions we've seen, this function can also be transformed, and its transformation is written f of x equals a over x minus h plus k. And you'll see the familiar letters that we've seen in many of our other transformed graphs, the letter a, the letter h, and the letter k. If a is a positive number, then the graph is in the first and the third quadrants, as we saw up above with f of x equals 1 over x. If a is negative, then the graph is in the second and the fourth quadrants. If the absolute value of a is between 0 and 1, that is, if the absolute value of a is a fraction between 0 and 1, then the graph is closer to the origin and closer to the axes. If the absolute value of a is greater than 1, then the graph is further from the origin and the axes. If h is a negative number, the graph is translated h units left. If h is positive, it's translated h units to the right. If k is negative, the graph is translated k units down. And if k is positive, the graph is translated k units up. The graph of the reciprocal function has two lines called asymptotes. An asymptote is a line that the graph of the function approaches but never crosses. Let's go back and take a quick look at our original parent function here, f of x equals 1 over x. You'll notice that the x-axis is an asymptote because this part of the graph approaches the x-axis, but it will never touch it. And this part of the graph, the y-axis, is also an asymptote because it will never approach that there. Notice that x cannot equal 0, which is part of the reason why the y-axis is an asymptote. Okay, let's go back and talk a little more about asymptotes here. The graph of a reciprocal function has two asymptotes. It has a vertical asymptote at the line x equals h. So whatever the value of h is, remember that value of h, if it's equal to x, it's going to make the denominator 0. So that cannot be. So that would give you a vertical asymptote. And it's also going to have a horizontal asymptote at the line y equals k. So there's going to be a vertical asymptote going up and down, a horizontal asymptote going left and right. Since the graph of the reciprocal function will never cross the asymptotes, x can be any value except for h. So its domain is x is all real numbers except h, or x is not equal to h. And y can be any value except k, so its range is all y values except for k, or y is not equal to k. So let's take a look at a couple examples here. We need to graph each reciprocal function, identify the vertical and horizontal asymptotes, and the domain and range. So for number 1, we have f of x equals 1 over the quantity x minus 2 minus 5. I actually like to start by identifying and graphing the horizontal and vertical asymptotes. I'll notice from the graph here that h is equal to 2 because h is the number that's being subtracted from x, and k is equal to negative 5. That's the number that's being added onto the end of the fraction. So I'm going to have a vertical asymptote at x equals 2 and a horizontal asymptote, because remember the vertical asymptote is at x equals h, and a horizontal asymptote at y equals k, or y equals negative 5. And I'm going to go ahead and draw those on my graph. I'm going to draw them as dashed lines. You could do them in a different color if you'd like. So there's my vertical asymptote at x equals 2, my horizontal asymptote at y equals negative 5. Okay, and that tells me a lot about what the graph is going to look like. I also noticed that a is equal to 1, so that's a positive number, so I know that my graph is going to be kind of in this, not necessarily the first quadrant, but kind of to the up and right of my asymptotes, and then I'm going to have a piece of the graph down here below and to the left of the asymptotes. So in order to get some points to graph, I'm going to make a table of values. And I actually used my calculator to help me with this. one thing I'm going to do is I am going to put the value of my vertical asymptote right in the middle of the table because I know that x cannot equal 2. Notice that when x is 2, I have 1 over 0 minus 5, and I can't have 0 in the denominator of a fraction. So using my calculator, I picked a couple values of x that were greater than 2, and when I chose 2.5, I got y as negative 3. When I chose 3, I got that y is negative 4. And when I chose 4, I got y is equal to negative 4.5. Go ahead and choose values of x that give you reasonable numbers to graph. And then a few numbers less than x equals 2. I chose 1.5, which gave me negative 7. I chose 1, which gave me a negative 6. And I chose 0, which gave me a negative 5.5. So let's go ahead and graph those and see what it looks like. So when x is 0, y is negative 5.5. When x is 1, y is negative 6. And when x is 1.5, y is negative 7. So that gives me the piece of the graph that looks like this. And make sure that when you're drawing it, you draw it so that it looks asymptotic, so that it's approaching that asymptote but not quite touching it. Don't make it curve back out and look kind of like a quadratic graph. And then I have 2.5, negative 3, which is this point right here, 3, negative 4, and 4, negative 4.5. And I know basically what it's going to look like, so I don't need more than probably 3 points for each piece. So there's my graph, and that makes sense. So that's basically f of x equals 1 over x, which looked something like this, translated 2 units to the right, because h is equal to 2, and 5 units down. My domain is x is not equal to 2, and my range is y is not equal to negative 5. So x can be all real numbers except 2, y can be all real numbers except negative 5. Let's take a look at a second example here. F of x equals negative 2 over x plus 3. Notice that h is equal to 0. There's nothing being subtracted from x, and k is equal to 3. So that means I'm going to have a vertical asymptote at x equals 0, which is actually the y-axis. And I'm going to have a horizontal asymptote at y equals 3. So I'm going to start by graphing those. So here is it's a little hard to see here, but there's my vertical asymptote. Again, if you'd like to do these in color, feel free to do that. And a horizontal asymptote at y equals 3. I'm also noticing that a is equal to, well, I can make that a plus and put the minus up there. So a is equal to negative 2, which means that a is less than 0. So my graph, instead of being kind of up and to the right and down and to the left, my graph is going to be up here and down here, the two pieces of it. So let's go ahead and make a table of values. And I'm going to start with x equals 0 in the middle of my table because I know that x cannot equal 0. And then choosing a few values, and I used my calculator to help me with this, of x that are greater than 0. Here are the y values I got. And then a few values that are less than 0. Notice sometimes you'll have to do halves, but that's okay. It's actually not that hard to graph a half. And graphing those. So when x is 1/2, I have negative 1. Whoops, that's positive 1. Negative 1. And then I have the 0.11, and then I have the 0.22. And so that's going to look like this. And I'm noticing that, yes, this is a little bit wider, which makes sense because the absolute value of a is greater than 1. And when I have negative 1/2, I have 7. Negative 1 is 5. And negative 2 is 4. And again, I'm making this look asymptotic. It's approaching the asymptote but not touching it. Okay, and my domain is x is not equal to 0, and my range is y is not equal to 3, because those are my asymptotes. So in this video, we took a look at how to graph a reciprocal function. The basic parent reciprocal function is f of x equals 1 over x, and it can be translated left, right, up, down, wider, narrower in two different quadrants based on the values of a, h, and k. Unique thing about reciprocal functions is they will have two asymptotes. They'll have a vertical asymptote at the value x equals h and a horizontal asymptote at the value y equals k.